containing monthly data collected over a year at Port Dickson and Port Klang. These are common measurements carried out in marine microbial ecology. We measured chlorophyll A concentration, ammonium, phosphate, nitrate, salinity, total suspended solids, dissolved oxygen, silicate, temperature, and bacteria. And the students are asked to test the following hypotheses. First, the average chlorophyll A, ammonium, phosphate, and nitrate concentrations between Port Dickson and Port Klang are similar. So this is basically a comparative test between Port Dickson and Port Klang. However, some students used a two-way ANOVA to do this, and this is wrong because you cannot be comparing things that are different. Okay, these are different measurements. You can only do a two-way ANOVA with one factor as Port Dickson and Port Klang and the other as measurements if the measurements are similar, which means if chlorophyll A is at maybe January, February, March, and April, then you can test the chlorophyll A means at different months and compare it with another factor which is different stations. Okay, but you cannot do a two-way ANOVA with different measurements. Okay, so the proper way is to carry out a t-test. Therefore, you have to carry out a t-test for chlorophyll A, phosphate, and nitrate separately. Okay, so this is what one of the students did. They carried out a t-test for two samples, chlorophyll A concentration at Port Dickson and Port Klang, and do a comparison. Okay, for chlorophyll A, ammonium, phosphate, and nitrate. However, here one of the problems I observed was the interpretation of the results. T-stat is the t-value obtained from the comparison of this between these two columns. Okay, so as I mentioned earlier, we will stick with two-tailed tests because essentially two-tailed tests are more stringent, and if it is significant at two-tail, it will be significant for one-tail also. Okay, so let's just look at this. We have T critical two-tail and the P two-tail. So what is T critical two-tail? T critical two-tail is the T value at P 0.0 at probability less than 0.05. So if at P 0.05, the T should be 2.178. Therefore, if for the difference to be significant, or for these two columns to be not similar, your T stat value has to be larger than your T critical. Okay, so this has to be larger than this. The P at two-tail actually indicates what the P is at your current T stat. So immediately you can see that the P value is 0.188, which is more than 0.05. That means there is no difference between these two, or that means you cannot reject the null hypothesis. That means the chlorophyll A concentration at Port Dickson and Port Klang are similar. Okay, so there is no difference. So the student has wrongly interpreted the results. So here, another example, ammonium concentration, average ammonium concentrations at Port Dickson and Port Klang. Here you can see that the T-stat is 2.9. So T critical at 2 tail is 2.13. So which means the value here is larger than the value here. This T critical is at P 0.05. That means your T stat is at P less than 0.05. If you look here, it matches. Okay, so the P here is at 0.01. So that means you can reject the null hypothesis that these two are similar. So there is some that yeah, so you can reject the hypothesis, the null hypothesis that these two are similar. Another thing that I would like to point out is the negative value here, the negative sign here doesn't mean it's smaller than this. The negative sign is just a directional sign to say that this is less than this. Okay, so you should take the absolute value of 2.9 instead of uh, thinking that it's negative 2.9. So the absolute value of 2.9 is larger than 2.1. Okay, so that's how you should be interpreting the t-test table. Okay, next for question number 2. For both Port Dickson and Port Klang, is chlorophyll A associated with any of the following? Ammonium phosphate nitrate. Okay, so we are looking at association statistics. Okay, so what you should be doing is probably you should be doing a correlation test first. Then if yes, what is the linear equation that can describe the relationship? Okay, so you should be carrying out a linear a correlation test first. Okay, so this is another mistake that some students have done. Immediately they did a multiple multivariate linear regression where they put all three, ammonium, phosphate and nitrate, as their variable in the linear regression test. So this is not the right way of doing this because you are actually supposed to test the association against each first. So chlorophyll A against ammonium, chlorophyll A against phosphate, chlorophyll A against nitrate. So usually if the correlation is significant, let's just say for ammonium and phosphate, only then we will do a uh, multivariate linear regression using both the significant ones. Okay, so multivariate linear regression is only done uh, after you have found out the significant associations. A simple correlation test. You can also do a multiple univariate correlation in one table, and all of this are not associated. There's no significant correlation. Some students also did the additional step of removing outliers, so that is recommended. So outliers are removed when they are more and less than 2 times standard deviation. Okay. So the last question is, how would you transform the bacterial abundance data, and after transformation, is there any association between bacteria and chlorophyll A? Plot a suitable graph to show this. So bacteria is count data. So most of y'all did the right transformation, which is log transformed the bacterial data. So after transformation, you looked for association using correlation. And since there is no significant correlation, then that's the end of the question.